Welcome to episode 14 of my calculus series. Today, we're diving into implicit differentiation. Ever wondered how to take the derivative when y isn't isolated? By the end of this episode, you'll not only know how, it'll start to feel easy. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. Why implicit differentiation? Not all equations allow us to solve for y in terms of x directly. Take for example, x squared plus y squared equals 25. This defines y implicitly, but we still want to find dy dx. That's where implicit differentiation comes in. How it works. Differentiate both sides of the equation with respect to x. Treat y as a function of x. That means, whenever you differentiate a term involving y, apply the chain rule, and multiply by dy dx. Here's an example. The derivative of x squared plus y squared equals the derivative of 25. That gives us 2x plus 2y times dy dx equals 0. Now solve for dy dx. Basic example. Let's differentiate x squared plus y squared equals 25. The derivative of x squared is 2x. The derivative of y squared is 2y times dy dx. So we get 2x plus 2y times dy dx equals 0. Solving for dy dx. Dy dx equals negative x over y. Next example. Differentiate x times y equals 1. Using the product rule, x times dy dx plus y equals 0. Now solve for dy dx. Dy dx equals negative y over x. Intermediate example. Differentiate x cubed plus y cubed equals 6xy. The derivative becomes 3x squared plus 3y squared times dy dx equals 6y plus 6x times dy dx. Move terms. 3y squared times dy dx minus 6x times dy dx equals 6y minus 3x squared. Solving for dy dx. Dy dx equals 6y minus 3x squared, over 3y squared minus 6x. Another intermediate example. Differentiate e to the x plus e to the y equals x plus y. Derivative becomes e to the x plus e to the y times dy dx equals 1 plus dy dx. Now isolate dy dx. Left side, e to the y minus 1. Right side, 1 minus e to the x. So dy dx equals 1 minus e to the x, over e to the y minus 1. Next, differentiate natural log of xy equals x plus y. Start by taking the derivative. Derivative of natural log of xy is 1 over xy, times y plus x times dy dx. Set that equal to 1 plus dy dx. So the left side becomes y plus x dy dx, over xy equals 1 plus dy dx. Now solve for dy dx. Advanced example. Differentiate sine of x plus y equals x squared. Take the derivative. Cosine of x plus y times 1 plus dy dx equals 2x. Solve for dy dx. Dy dx equals 2x over cosine of x plus y minus 1. Another example. Differentiate x squared y plus y squared equals x. Apply the product rule. Derivative of x squared y is 2xy plus x squared times dy dx. Derivative of y squared is 2y times dy dx. All of that equals 1. Now group the dy dx terms. X squared plus 2y, all times dy dx equals 1 minus 2xy, so dy dx equals 1 minus 2xy, over x squared plus 2y. Last example. Differentiate y squared plus xy equals cosine of x. Take the derivative. 2y times dy dx, plus x times dy dx, plus y equals negative sine of x. Factor dy dx. Dy dx times 2y plus x equals negative sine of x minus y. So dy dx equals negative sine of x minus y, over 2y plus x. Summary. Key points to remember. Use implicit differentiation when y is not isolated. Differentiate both sides of the equation with respect to x. Every time you differentiate a term with y, multiply by dy dx. After differentiating, solve for dy dx algebraically. And that wraps up today's episode. If this helped you out, don't forget to like, follow, or subscribe for more lessons. Thanks for watching, and see you in the next one.